Hey, thanks for joining us. We're going to talk about sound transmission class, just the noise passing through walls, floor ceilings. And I'm Bill Holliday. This is Kemper Brightman. We're with Noise Engineers. All right, why don't we start with, I'll start with definition of what it is. So a lot of times we use this classification or this descriptor, sound transmission class, or STC, to describe noise going through, or how much is attenuated going through a partition. The higher the STC, the more efficient, the better that barrier is at reducing noise. And generally, it's for speech, human speech, I guess television, stereos, but it's not going to work well with low frequency noise. So this descriptor, just real general about an STC 30, is about a reduction of 30 dB in speech. That normal speech could be heard and easily understood through that type of partition. If you have an STC 40, loud speech could be heard, maybe loud speech could be understood. An STC 50, we're saying loud speech is difficult to even detect, maybe a word here or there. 55 and above, speech at least is not that audible. Now that's with just an STC. They have these curves that you see, you know, where you're landing on those curves, that average reduction. All right, Kemper, you want to talk about types of projects, how we deal with this?
Yeah, absolutely. So we have many different types of projects that we've dealt with. A common one recently that we've been doing a lot is certain cities and counties have different regulations about the community noise equivalent level. And that can relate to airport contours. So if you're near an airport or maybe near a noisy highway and you're building something, you might get a notice that says, hey, we need you to verify that your construction is going to bring down the interior noise to, in general, it's 45 dB, or that's a community noise equivalent inside there. So what we do is we check the construction and make sure that actually, if you do have a loud exterior noise of 60 dB or above, that whatever you've built and designed is actually going to make it so that inside you're not hearing all this loud traffic noise or loud airport noise all the time. So that's kind of the exterior variant of STC. We've also done hotels and offices plenty. Hotels are generally concerned with floor ceiling and walls in between suites. So for floor ceiling, we also use the IIC, which is impact insulation class, and that's kind of telling us if there's someone stomping or if they're dropping, something on the ground, how easily will you be able to hear that through the partition. So that's one way that we evaluate floor ceiling. Walls, we also check SBC to make sure that you're going to get the level of attenuation that you need. You don't want to have a gym or a nightclub blasting music next to your offices if you don't have a wall that's designed to take care of that noise so that you're not constantly listening to someone else's music or their own conversations. Another thing that we do really frequently is we look at in the inside of offices. On occasion, people will come into a new office, create a really nice space, and then realize pretty quickly that they can actually hear the coworkers through the walls. And part of what goes on is that the walls are not properly designed to take away from that level of noise. So we can come in, test, look at the construction, say, hey, this is how we recommend you change this to meet the requirements or to meet your needs based on the measurements and the observations that we've made in the space. And it actually makes a huge difference. If you're a CEO or someone in human resources, you don't want to have to be whispering on the phone if you have to have an important conversation, and you don't want someone who's in a completely separate office to not hear. So go ahead.
Yeah, that's good. And so a couple of the things I was thinking of, when we're looking at some projects, we'll actually look at not just the STC, but look at the octave noise reduction. And we'll look at the background noise in the receiving room to make sure speech privacy is taken care of or covered. We'll also, if people convert apartments to condos, they need to meet this uniform building code. And that's an IIC and STC criteria. And you can either laboratory test meet it, and it's usually a 50, or you can field test it, and then the criteria is five points lower. And I was going to say, we do end up doing a lot of testing. So we test the sound transmission class, STC, and we also test the impact insulation class, the IIC. I don't know, you want to talk about testing the STC?
Yeah, absolutely. So one of the ways that you can test the STC, and it's actually called, when you're testing it in the field, it's called the ASTC, which is the assumed sound transmission class, which kind of just accounts for the fact that there's variables in there that you don't have in the laboratory. So it may be less just based on your construction. So when we're testing the ASTC, we're going to blast loud music in one room and measure essentially how much of that is coming into the next room. So we do a background level check without any music on the receiving room. So we see how loud that is. And then we blast music in another room, measure how loud that is. And then we go back to the receiving room and test and see how much of that is coming through the wall. So that's going to tell us if the background's here, and when we play, it's not music, by the way, it's white noise that we're playing.
Which is a constant broad spectrum noise. So you're getting noise in every octave band, or every third octave band is what we're testing.
Right, exactly. And then we test that based on what the background noise was. If this is what it is when you have 100 or 99 dB in the room that's emitting that broadband sound, then that tells us the ASTC of the wall. Tells us exactly how much is coming through based on the construction.
Yeah, we want to make sure in the receiving room that the noise produced by that pink noise, that broadband noise, is actually above the background noise, so it's not being influenced. And we're really measuring the noise coming through that wall or floor ceiling system. And then we do a quick room correction to kind of normalize that receiving room. We could do a reverberation time test, just take into account that room absorption to make it standard. And then we get the standard STC level for the wall. And sometimes that's needed. I think we had some government project where they needed an STC testing to make sure it meets some criteria. So we'll go in and test and make sure it is. But even if we don't know what the construction is really well, that can help us get an idea of what is that wall, what's it producing, and then what will different treatments help add on to that. How about, you want to talk about the program, the Insul program?
Yeah. So we use a program called Insul that helps us evaluate, remotely evaluate STCs of a given construction. So this means that if you're somewhere else and you want us to come evaluate your project to make sure that you're going to meet the community noise equivalency level for airport or road noise or some other sound source, can be trains. We can take your construction, take your building plans and those details and put it into Insul, which is a calculator. It's going to take an input, so we can go through and say, okay, one layer of gypsum, this is the stud spacing, these are the type of studs, and it's going to tell us the STC of that. And we include everything in that, including glazing, so windows, doors, walls, and your ceiling and roof. So it also includes a calculator that gives us the exterior noise, and then given the construction that you're proposing, what your interior noise level is going to be. So we can tell you about it.
And another cool thing better. Yeah, go ahead.
No, I was just saying that the program can give us a bunch of options and say, okay, if you add this, an extra layer, then you may get this much reduction, or if you have windows that are STC 30, that's not going to cut it. You need better windows. And it actually can save people a lot of money in the long run instead of having to replace things.
Yeah, and it shows how much is coming from each component, so you know which ones to treat. And noise transmission, it's really limited by the weakest link. Really can hurt your sound transmission into a space. So you could have great walls, great roof ceiling, and have weak windows, and you're not going to pass. And so that'll identify, which components are your problems and where to treat first. The other nice thing with the program is you can add different treatments and see how that improves it. So if you add insulation or go to staggered studs or add a layer of gyp, it'll show you the increase, and you can determine, in this case, if it passes, but in other cases, just is it going to make a significant difference? How much do we need, or what type of options will get us to our objective or our goal?
Yeah, exactly.
So, in general, you want as big of an air cavity as possible. If you have 2 layers, I'm thinking of a wall stud system. The bigger the air cavity, the better. Insulation definitely helps. You don't want to overpack it, but having it filled with insulation helps considerably. Adding more mass on the exterior helps. You get diminishing returns as you start adding layers. 1 more layer when you already have 4 isn't going to be that noticeable, but doubling the mass does make a difference. You can also, any resiliently disconnecting either the walls or the floor ceiling helps considerably. So having dual studs that are separated makes a big difference. Floor ceiling, hanging your ceiling on resilient channels or spring isolators helps considerably. It just decouples the sound, converting into vibration, converting into sound, and then coming through vibration into that final layer. If they're decoupled, you minimize those paths and make it a lot better sound transmission.
Yeah, absolutely. I was just going to talk about some more. We're talking about solutions, or just want to?
Go ahead, whatever you got.
Yeah. Well, I was just going to say that I think another thing that I see a lot when I'm out in the field looking at this stuff is that you can have an amazingly well-designed wall, but if you have a pipe that passes straight through it, or a duct, or maybe you have a couple outlets that you've set up back to back because it's convenient for the electrician, those things can make a huge difference, because sound, being that it's a wave pattern, it can fit through small gaps. And so it makes a huge difference that you have those things properly sealed. You try not to locate outlets and any real penetration back to back through the wall. I was in a gym the other day, and they were wondering why I was really loud in the office next door. It turns out they had a 3-foot wide HVAC duct that went from one side to the other. So you could build the STC 80 wall, and if you have a 3-foot wide gap in it, you're going to get sound traveling through it no matter what.
Yeah, that's a great point. Is flanking paths, windows, doors tend to be weak links. Through the ceiling path can be an issue. You really, even if your wall's doing great, improving that wall might do nothing if you have other flanking path issues.
Yeah.
All right, I think that's good. Thanks for listening. We appreciate it. And if you have any feedback, feel free to contact us. We're at noiseengineers.com. Appreciate any comments, any questions, and take care. Bye.